At first glance, Antarctica appears as an endless, unbroken sheet of white, stretching all the way to the distant horizon. This ice sheet is 4.3 times the size of India, large enough to swallow the entire land masses of the United States and China combined. Surface temperatures here regularly drop to -50 degrees Celsius, creating an environment that appears entirely hostile to biological activity. For decades, scientific consensus viewed the continent as a solid, static landmass, permanently locked away under miles of ice. That perception changed with the discovery of blood falls. A thick, crimson liquid pours directly out of the glacier, carrying traces of rare elements like iron and gold from deep within the interior. The presence of this liquid at the surface proved that the ice sheet is a pressurized lid, sealing off a chemically active world below. Conceptually slicing downward through those thick miles of glacial ice reveals the hidden rocky bedrock at the very bottom of the world. This hidden landscape is jagged and active, containing 72,000 distinct hills and 138 active volcanoes. Snaking through this volcanic rock is an immense aquatic network, including a flowing liquid river stretching 740 kilometers in total darkness. That central river connects to 400 distinct subglacial lakes scattered across the continent. Water remains liquid here because of a mechanical paradox. Geothermal heat radiating from the volcanoes is trapped by the crushing physical pressure of the ice above, preventing the water from ever freezing solid. Antarctica's interior functions as one of the planet's most massive and dynamic aquatic plumbing systems. To sample this environment, research vessels like the RV Polarstern drill directly into the subglacial soil. Deep drill cores have recovered dark soil containing ancient fossilized roots and pollen. This evidence confirms that millions of years ago, this region supported a lush rainforest ecosystem. While the soil records the past, the water itself hosts the present. Thousands of species of microbes have been identified in these dark subglacial lakes, organisms that have evolved in total isolation since the continent first froze over. These subglacial systems act as a biological archive, preserving ancient lineages of life that adapted to the darkness rather than dying out. Reaching these lakes is a physically grueling and expensive process. Scientists endure these conditions because Antarctica is the most accurate earthly analog for deep space exploration. Comparing Antarctica with an ice moon like Europa, both feature a thick iced crust hiding a liquid ocean sitting on volcanic rock. Studying how Antarctic microbes thrive on chemical energy reveals the biological signatures to look for in our solar system's dark ocean.